Recall that a rational function can have three types of asymptotes: vertical, horizontal, or oblique. We've learned how to locate vertical and horizontal asymptotes, so now we're ready to study oblique asymptotes. Remember, oblique simply means at an angle to. For that reason, oblique asymptotes are sometimes called slant asymptotes. Here's how we locate them. Oblique asymptotes occur where the degree of the numerator is exactly one more than the degree of the denominator. So pause right there for just a minute and note the degree of the top is bigger than the degree of the bottom. This is the bottom case, bigger on top, which means there will be no horizontal asymptote. So an oblique asymptote does not occur simultaneously with a horizontal asymptote. If the degree of the top is exactly one more than the bottom, then an oblique asymptote will occur. To find the equation of the oblique asymptote, divide the numerator by the denominator. This can be accomplished easily with synthetic division. Disregarding the remainder, the equation of the oblique asymptote is then y equal to the quotient. So let's take a look at example 6. Find the equation of the oblique asymptote for h of x equals x squared minus 5x plus 6 over x plus 1. Now, this was the function that we examined on example 1c. So we'll locate the oblique asymptote and then we'll compare it to the actual graph. So what we want to do is divide the numerator by the denominator, and we're going to do this with synthetic division. So recall with synthetic division, we put the 0 of the denominator in this little box. Our denominator is x minus 1, so it is 0, its 0 is 1. Then we pick up the coefficients of the numerator on row 1. We skip a row and draw a baseline, and then we bring down that first number. So recall in the synthetic division process, we take the number in the box times the number on the baseline, so 1 times 1, that gives us 1, and we put the answer on row 2. Then we add vertically. Negative 5 plus 1 is equal to negative 4. Then we multiply again. 1 times negative 4 is negative 4, add vertically to get 2. So recall this last spot in synthetic division is the remainder. Also remember that if we started with a degree 2 polynomial, then our resulting polynomial is going to be 1 degree less. So those represent the coefficients of a degree 1 polynomial. So if we write the equation, or if we express our quotient, we would end up with x minus 4 as the quotient and remainder 2 over divisor x minus 1. However, like horizontal asymptotes, oblique asymptotes ultimately describe the end behavior of the rational function. On a large scale, either on the far right side or the far left side, this remainder is going to become smaller and smaller until it's negligible. So the behavior of the function is going to follow the quotient more closely. So the equation of our oblique asymptote then is y equals x minus 4. So once again, we divide the numerator by the denominator using synthetic division. We disregard the remainder, and so the equation of our oblique asymptote is then the pattern y equal to the quotient. Now let's take a look at the graph on example 1c. So here's our function. And we found out the equation of our oblique asymptote was y equals x minus 4. Notice the y-intercept of that line would be negative 4. The slope would be 1. So rise 1, run 1, up 1, over 1. You can see we have correctly identified the equation of our oblique asymptote. And also observe how the curve follows the pattern of that oblique asymptote on the far right side and on the far left side. So now that we know how to find all three types of asymptotes, vertical, horizontal, oblique, in addition to locating holes, we are ready to graph rational functions. And we'll do just that in the next video.